Okay, so from today we'll start with Spark. Okay, so before starting, let's try to understand the Spark architecture first. Okay, so within this Spark learning, right? What I'll do is I'll explain this Spark architecture multiple times. Okay, first thing I'll just give you one short interesting story. Okay, and then within this time period of learning Spark, you need to remember those this basically the interesting story. Okay, so with this, your understanding of this Spark will be really good. Okay,
Anuj, before going to Spark, I have a doubt.
yeah, yeah, right.
So, uh, to learning PySpark, or is it mandatory to learn pandas as well? To
Not necessary to learn because pandas that we are anyhow we are going to learn those pandas because in Lambda we are going to use that. Okay, AWS Lambda we need to use panda little bit. Okay, pandas and numpy, but if you are not wanted to learn this, nothing, no problem at all, because this is Spark. PySpark is completely different. Only
so
thing we
in interview level, can we expect pandas questions? Or
sometime it depends on your job description.
okay.
Okay, but if you have a clear understanding on Python, right, so
Mhm.
it's very easy to learn pandas, and it will not take more than 3 days to understand everything. And the same data frame level concept, what we are going to discuss in this PySpark, the same concept will be there, just a function and some methods are different there. Okay, so it will be easy to learn. Any other questions?
No, no, Anuj.
Okay. So I'll ask one question first, and then we'll start with this. So let's say I have 10 TB of data. Okay. Now, if I'll ask you to process this data, how you think to process? Can we run this in our local Python script? Because in Python also we seen, right, how we can load our CSV file or JSON file, and then we can do those kind of transformation by using some list, and then we have lots of methods, right, that we discussed in our dictionary part, list, tuple, those things. So can we do this, and then we will load this to, let's say, MySQL database? Is it possible to do with our system? If it is possible, how much time it will take?
So much time.
Right. Maybe it will take 3 days at least, more than that also. Maybe your system got crashed in middle of that, right? So now let's try to understand one very basic example, and then this concept you need to remember till the last of this Spark learning. Okay, so we'll be learning with this example only. So let's consider someone having one pizza store, let's say. Okay, so here we have this pizza store. Okay, now just stop me if you are not able to understand anything with this example, because with this example only we are going to understand everything, visualize everything in this Spark. Okay, otherwise it's very difficult to visualize. Maybe going forward, we'll see those DAG, and we'll see how it is working, but starting you'll not able to visualize the thing. Okay, so now this is the pizza store. Let's consider uh, sudden one day in this particular pizza store. Okay, so let's consider this is a pizza company, any pizza company. Okay, so suddenly one day what happened, one customer is there. Okay, one customer is there, he ordered almost 1,000 pizza, or more than 1 lakh pizza or something. So let's consider 1,000 only. Just these are the numbers. Okay, now what will happen with this store now? What this store will have to deliver this 1 lakh or 10,000 pizza at a time? Is it possible to deliver with one safe? Just answer me yes or no. What they need basically now to deliver it?
Anuj, can you come again once?
So what I'm saying is we have this pizza company. Okay, now one day suddenly this customer, one customer is there, he ordered almost 10,000 pizza at a time. And then what will happen with this pizza store now? What he'll do? Will they able to deliver this 10,000 pizza within 1 hour or 30 minutes like that?
No,
But that depend on the pizza. I mean,
Yeah, that is my
store
question.
capacity, right?
Yeah, that capacity. So capacity means what? In which capacity you're talking about? Maybe they'll have the good number of
Work
say, they will have the
workers.
good number of kitchen, right? They'll have the good number of ingredients and all, right? So they need to see all those things, right? If they have, they can do it. And if they have everything, then the timing is the concern. So same way, let's say 10 TB data that we are trying to process in our system, right? At that time, in our system also we have the CPU. In our system we have the RAM. Everything we have, right? Processors and memory, the connection, everything we have in our system, right? But why we are not able to process with our system within 30 minutes this 10 TB of file? Just think and answer me. Just think about this question. Okay, and will, if anyone wanted to answer about this, if they have any idea, just answer me. We'll just discuss the other thing. Okay, now this customer ordered almost 1,000, 10,000 pizza with this store now. Okay, so in this store there is some honor, right? We must have this honor, or let's say the manager of this store. Okay, so what is the role of this owner or manager? What he'll do? If he's getting this order, what he'll do?
Assign work to the workers.
No. First thing, let's start with basic. First thing is he'll take the order, right? He'll take the order. No? This manager and the owner, whoever is there in this store, the head person, he'll take the order, right? He only decide like he wanted to take this order or not. And then because he's the manager of this store, he will decide he will decide how to split this work. No, but why he need to split the work? Any idea?
to reduce the time.
Okay,
If all the pages go to same worker, maybe there is a lot of load.
okay. Anyone?
Because he knows it's not possible with one chef, so you need to split with different chefs.
Correct. Till here, you guys are good, right? Now, let's little bit change our example, and then we'll come to the same example again. Okay. Now, let's say this customer, let's take a small number again. So this customer, what he told that I want 120 pizza delivered in 30 minutes. What this customer ask is he want at least 120 pizza delivered in 30 minutes. Now, this manager, pizza store manager, what he'll do? First, this manager will look into his kitchen, right? Maybe this pizza store manager only having this uh, one kitchen. Now, let's consider this store having one kitchen only. So he'll not able to deliver this 120 pizza in 30 minutes, right? So what he did, this manager, he'll take some smart decision, and then what he'll do is maybe they are having some branches. Okay, so now they are having some different branches. Okay, because this particular store having just one kitchen, now this manager decided, let's go for other because we have other branches also in this area. Okay, so now let's say this particular pizza company having three branches. Let's say this A branch, B branch, C branch. Okay, so now what this manager will do is, first thing is he'll take the order, write the plan, because he need to make the plan, right? How much pizza is getting, how he need to deliver it, right? Are you guys following?
Yeah, Anuj.
Yeah, just a second. Someone is in the door. Yeah, sorry guys. Yeah, okay. So this manager, pizza store manager, okay. So what he did is, maybe he is the senior person, he knows all these branches. Okay. Now what he did is he make one plan. So here is the plan. Okay. He made one plan that, okay, I have 120 pizza order. Okay. I need to deliver this in 30 minutes. Okay, for this what he did is, let's take this order and split the work, so that we'll finish this quickly. Okay, faster. And then after completing everything, let's combine everything and deliver it to the customer. So he made this kind of plan. Okay, now he took this order for 120 pizza delivered in 30 minutes. Now for this, because he's not able to do, because he's just having one kitchen, right? So he's having three branches now. Okay, now what he did is, he's just splitting this task, because now he is having 120 pizza. What he did is he distributed, let's say for the store A, he distributed, you can take 40 pizza, you can prepare 40, you can prepare this 40, and you also prepare 40. So now he divided this task, this manager. Okay. Now this store, now all the task is divided for the 40 pizza. Now inside each branch, okay, let's go inside this branch and see what is the problem here. Now inside these branches, let's say the uh, A branch A. Okay. So what he'll do is, maybe here we have two shapes, A1 and A2. Here we have B1 and B2. Here we have C1 and C2. Now these are the safe. Okay. So this A1 safe will do 20 pizza. He'll do 20. He'll do 20, and this B2 will do 20. Same way, C1 will do 20 pizza, and this person C2 will do the 20 pizza. Correct? Now let's discuss one important case here. Okay, later when we'll discuss some other topics, I'll ask this example again. Okay, so I'll ask one question here. If let's say the ingredients are missing in some branches, what will happen? So let's say this, in this branch some ingredients are missing. Let's say this having some less cheese. Okay, and they are having some extra cheese. They are having some less dough, and they are having some extra dough, like this. So someone having some missing thing, someone having some extra thing. So what they need to do now?
Exchange.
Exchange. Correct. So let's say this branch A has some extra cheese, branch B has some extra dough, branch C has some extra toppings. So what they need to do? So they send the items between branches using some delivery guys, because someone need to deliver this. So let's say here is a delivery guy for us. So for these delivery guys, for the exchange of this item, what they need to do? They need to do the packing again, right? They need to do the packing, and then they need to send it, and then the receive will also happen. Someone will receive the order again. Let's say if this branch A having some extra cheese, he'll send it to branch C. Now this delivery person will take that cheese and he'll move toward this C. So he'll get this packing, they will do this packing, and then they send this cheese to this branch C. Now someone from branch C will receive this, right? So this is again taking some time, and maybe because of this delivery person is going from this traffic, so he'll face some of the traffic delays. Correct? Correct. So once all the pizza ready, all the pizzas are packed. So in this branch A, all 40 pizzas are packed. Branch B, 40 pizzas are packed. Branch C, 40 pizzas are packed. Now what will happen? They'll send all this thing to the driver, like this manager. Okay, and then this manager will deliver this pizza to the customer. Like this, can we prepare this 120 pizza in 30 minutes? Yes or no?
Yes.
Yes, right. So what
But
will do here?
Anuj, I have a doubt here.
Yeah,
So let's say you are saying that ABC are three groups, right?
yeah, correct.
So in that A1, A2 make the pages by 2020, right?
Yes, correct.
So take an example in the group B. Suppose if B2 don't know how to make a pizza.
Mm-hmm.
In
They are
that
the
case,
safe. They are the safe only, right? Because this is the pizza company. They hired the chef only because they know how to make this pizza, right?
Okay.
Now, one question. This is just an example. Just remember all this concept. Okay, we'll relate with our Spark architecture. And now, one question here with this story. What do you think? Which step is slowest? I'll give you the option. Splitting the work, safe they are cooking in parallel, and the third one is exchanging the ingredient between the branches.
A parallel.
No, parallel work
Exchange.
is always faster, right?
You are asking about which type
I'm
is
asking
taking too
about
much time.
which step is slowest one.
Okay.
Okay.
Exchanging one.
Yes, correct. So the exchanging ingredient between the branches is slowest one, right? So now, because it involves some packing, it involves some sending the ingredient to here and there, and then there is some network or the traffic delays, and then let's say this C, because they don't have the cheese is coming from this one A, so they need to wait till the time they will get that extra cheese, right? So they need to wait. So this is the most expensive step in complete Spark. Okay, so this step we will call every time is shuffle. Every time, if I'll call this as a shuffle, just think like something is getting exchanged from here to here, and all this thing, all these branches are our partition. So whenever I'll talk about the partition, just consider that these are the branches. Okay, so here we have two new words, that is shuffle and partition. So every time I'll talk about the partition, just think like these are the multiple branches we have, and every time I'll talk about this shuffle, just think something is dead. Something means what? We are dealing with data only, so data is getting exchanged from this to this. That means these are the partitions. So if this shuffle is happening, that means from this partition some data is getting shuffled from this or this, like that, right? So every time in the complete Spark, okay, later one will discuss about the scenarios questions, right? So that time also you'll see 80 to 85% of questions are related to shuffle only. Okay, till now, if any single or small doubt also, just let me know, because these are the very small thing but very important. Okay, so I think everyone understood this. Last question, and then we'll go to our first example. One question here. Let's say if each branch had all the ingredients already there, would we need to exchange anything at that time? Yes or no?
No.
No.
No, right? So that means there is no shuffle, because all the branches having the all the ingredients, then no need to exchange anything. Okay, so if there is no shuffle, we are calling this as a narrow. Just remember this narrow transformation. Just remember this word. If there is shuffle between the partitions, we will call this as a wide transformation. Okay, just remember these two words. Shuffle means wide transformation, no shuffle means narrow transformation. When the shuffle will happen, if all the partitions Well, wanted to exchange some data from here to here, here to like this. If no exchange, that means there is no shuffling, no transferring of this data. Okay. Now, coming to our first example, what we are discussing, one customer provided 1,000 pizza order, right? Now, we have a owner, or let's consider this as a manager. Okay. So once he got this request that I have 10,000 pizza order from the customer, what he'll do? First thing he'll do is he'll take the order. Okay. Then he'll decide, means he'll make one plan. In previous example, if you remember, first he made one plan, right? So he'll decide how to split this work. At that time, they have three branches. Now maybe they have 50 branches. So they'll decide. Okay. Third one, he'll decides, also he'll decides which branch will cook. That also he'll decide, right? Fourth one, finally, at last example also, after all these three branches, prepared the 40 pizzas, and then he'll sending back to the manager or the owner only, right? So this person, owner or manager, is also responsible for collecting the final result. Any problem here in this 3 point? No? Okay. So with this, what we understood till now is this owner or manager, this person, right? He does not cook, right? What he's doing? He's just planning. He plans the thing. He assigns the task, correct? He monitors everything. This three thing is doing now. Got it? Now, suppose let's again take the this particular pizza company having three branches again. Okay. Now, this is again branch A, branch B, and branch C. Okay. Now, so how the allocation we need to do now? For the allocation, what he need to think? What he'll think? First thing is, for the allocation system, what they need to decide? How many pizza each branch will make, right? Because let's say this time he is having 1,000. Maybe he'll having sometime 100. Sometime he is having 1,000. Okay. Sometime he is having 500. So he'll decide which store will make how much of pizza. So he'll divide equally then. Okay. So he'll divide something to this branch, he'll divide something to this branch, he'll divide. Now because we have 10,000 or 1 lakh pizza, so he'll increase some branches later on, right? If we'll add the branches like this, then work will be more faster. Okay. So we'll come to this part on also. So for now, just consider is having this three branches, and now based on some branch capacity, he'll decide how much of pizza he need to assign to which branch. Okay. So that means what? Again, he does not cook. He only assign the what?
Work.
So this person makes the plans now. Okay. Now, for all this thing, who will take care of inside this? What is the capacity? Because every branch having some their own capacity, right? Maybe this particular a branch will only deliver 100 pizza at a time. This one, maybe he deliver 200 pizza. That depends on the safe only, right? Maybe he is having 3 safe, maybe he is having 2 safe, maybe he is having 5 safe. So obviously this branch C will deliver more pizza. So who will take care of all this safe? Who will recruit all this safe? For that, we'll have one manager again. Maybe this person will directly communicate with this manager, and he'll just tell him that, okay, hey, I have this one 10,000 of pizza. Can you assign me this resources where we have, right? So we can consider this manager as a central allocation system. Let's consider for now central allocation system. Okay. Now he'll decide in this branch whatever things they, maybe for cooking this pizza they need some oven, right? They need some toppings, right? They need all the ingredients. Who'll take care of all this? So they'll come to this manager only. They'll not directly go to this manager, right? Because he's the owner. They'll discuss with this manager, hey, I want this oven, right? Hey, I want this, I want two more safe, right? So he'll take care of all the resources like that. Got it? Now every branch A, branch B, and branch C, every branch will have the kitchen, right? Branch A kitchen, branch B kitchen, and branch C kitchen, right? So kitchen, and then oven, and then some storage also. Okay, same for this one also, oven and storage, oven and storage, like this. Okay. Now this branch receive the work from this manager directly, right? Now safe inside this branch is now what's their role, what they'll do. So inside each branch will have the multiple safes. Each safe work independently. Safe will cook the pizza in parallel, right? All these statements are correct. No? Now let's discuss about the individual pizza. Individual pizza means this is the smallest unit of work that one safe is doing, right? So each pizza is smallest unit of work, right? Because we have 10,000, we divided into like this. So now each safe is doing some one pizza like that. So all the task is divided into small task. Now let's clear it. Now let's discuss about the Spark architecture. Inside Spark architecture, you'll find one driver is there. Okay. And then we'll have the cluster manager. Okay. And then we'll have multiple executors like this. Okay. And this will do multiple tasks like this. These are the tasks. This is our Spark architecture. All these are the tasks they are doing. Okay. Now let's relate this with our example. So driver, this driver, I'll call this driver as a main manager, owner. basically. Okay. So this cluster manager is our allocation system. Okay. Branch kitchen. We have the kitchen here, right? So they are the worker node. Just remember, they are the worker node. All the safe there, they are the executor. All the single pizza is your task. Okay. Now we'll relate with our real time one. Okay. Now I'll just take one small note and then we'll compare everything with our real time, real Spark architecture. Okay. So this main manager is our driver, and then we have allocation system. This is our cluster manager, and then we have branch kitchen. So this kitchen, we will call this as a worker node. Okay. Now we have the safe. So the safe, we will call this as a executor, and then we have a single pizza. We divided the big task into small, right? So we will call this as a task. Just remember this five things. Okay. Now it's very easy to understand. So driver is our main manager. What is the responsibility of driver? Let's understand. Okay. Can anyone want to try at least what this driver will do? Whatever the Spark code you'll write, right? Whatever. Okay. This driver will reads your code. Means he's taking your order, right? Writing a program means what? You are giving instruction, correct? So this driver will read your code. After that, what he'll do? He'll create some execution plan. So later we'll discuss about this plan, that is our DAG. Okay. So DAG will look like this. Let me show you. This is the DAG. Okay. So like this, our your DAG will look like. Okay. Now, what else this main manager will do? He'll divide, right? Divide, and then he'll also create a task, right? And it will send this task to executor. Here, one important note is your driver does not process the data. Now, can anyone want to relate this with our pizza store owner or manager? Is it matching with that work? That guy is doing the same thing,
Yes.
right? Now, next, we have one manager, that is allocation one. So for that, we will use a term cluster manager. Cluster manager means he is a managing the resource. Okay. So he is a resource allocator. Okay. So what is his job? So we have multiple type of cluster manager. Like we have some. We'll learn one by one everything. a standalone yarn Kubernetes. Okay. So these are the type of cluster manager. Mostly we are using this yarn, and nowadays most of the companies are looking for Kubernetes. So this one is like the advanced one. Okay. Now, what this cluster manager will do? Any idea? Because whatever the keychain and all we discussed, right? So because we are dealing with the data now, so all the system now, whatever the example we took for the kitchen and the branches, right? So in our term, those are the machines like our system, right? So here, all the machines, they'll have the CPU, right? They'll have some memory, correct? So this cluster manager will take care of all this thing, CPU and memory. Okay. So allocation of your CPU and memory is taken care by cluster manager, and he'll also decides where the executors will understand what it means. Okay, so that means this cluster manager is also, it does not process the data, right? Now coming to the worker node, what this worker node will do? Then in our example, this is the branch kitchen. Okay. What will do? This worker, what will do? This is the machine, actual machine, okay, who host all the cluster. Inside this, only will have those safe and all, right? So that means we'll have the machine in cluster. We'll understand this part also. It will host the executors, okay, and it will run your task. Now we have a executor. Executor means safe in your example. Okay. So actual work is done by this guy's executor, safe. Who'll prepare the pizza? Safe, right? So actual work is done by, so that means this executor lives inside worker. They will execute data in memory. Will understand why I'm writing in memory. Okay. And it will store data in memory. Okay, because they have all the storage in their kitchen only, right? And it will send the result back. So that means if executor has 4 core, so that can run 4 tasks in parallel. What it means? Can anyone want to explain this line? Last we were left with this is task. Task means your single pizza. Okay. So task means your data is divided into partitions. Okay. Also, each partition is equals to one task. That means if you have 100 partitions, if you have 100 partitions, that means that will become your 100 task is created. Now, let's understand this complete thing. Can anyone want to explain? First thing, step one, your driver means your manager, this person, driver. He'll create a plan, right? Then step two, cluster manager. What he'll do? He'll allocate the three worker, that three branches. Okay. Now, step three. Step three is very important. In step three, what will happen? Guys, if you guys are not getting, just let me know. Because this is very, very important. You will not able to cover all this if you're not able to understand. Because if you see the topics here, everything is related to this example only. All this also. Okay. Not able to get anything after that. So what I'm saying is your manager means your driver creates a plan, right? Step two is your cluster manager who allocate the three workers are nothing but your what? Branches. No.
So according to that plan, the cluster manager will allocate the resources, right?
Ah, correct. So cluster manager will take care of all the resources. Okay, all the resources. This guy, driver, will only create the plan. Only creates the plan. He'll divide the task. He'll just create the plan. Okay, other thing is taken care by this cluster manager. Okay, now he creates the plan. He divide the data. Okay, so this task also he created. Also, he is sending it to executor directly. See, it is sending it to executor. This cluster manager is just providing. That means there is a link between this driver and cluster manager, right? Now, so if you look into the Spark architecture, we'll draw the diagram also. Spark architecture is looking like this. Here is your driver, here is your cluster manager, and these are the executors like this. Executor 1, executor 2, executor 3. We'll have multiple executor as per our data grows, right? So for now, we just need to understand this part, this two, and little bit of executor. Okay. So that means this cluster manager, what he'll do, he just allocated three worker. Worker means the branches. Now, the step third, this is very, very, very important. This one sends the data to executor. Who will assign this executor? This cluster manager. Once this cluster manager assign this executor, then only this driver will send the task to the executor. Got it? Step third means driver already created the task, right? Also, we what we discussed, if we have just think, if you have 100 partition, that means you can consider these are the 100 tasks. That means whatever the data you have, let's say you have 1 GB of data. Okay. Now, driver divides this into the multiple partition. So we'll learn all this thing. So by default, it will divide into 128 MB partition by default. We can change it also later. So if one partition size is 128 MB, total data is 1024 MB. So how many partition will get created here?
1024 divided by 128.
Yeah, how much? Around 8 partition, no? Exact 8 partition.
Yeah.
Okay. So 8 partition means what? 8 tasks will get created here. No? Till here everyone is good? Any confusion? So by default, I'm saying 128 MB. That means your driver will divide your task into 8 partition. Also, what I'm saying, if you have 8 partition, there will be 8 tasks created. So that this 8 task is getting assigned to the executor. Okay. Now you have 3 executor only or 2 executor only. So how many tasks is given to each executor now?
4.
4 tasks to this executor, 4 tasks to other executor. That means it will do this 4 tasks parallel, right? Now, if you want to do this little faster, what you need to increase? Let's say,
Executor.
uh, which one? Executor, correct? So if we'll have 4 executor, that means one task is assigned to one executor. No? So it will be faster. So this concept we'll learn later. Just focus till here. What this cluster manager is doing is assigning the executor. After getting assigned this executor, just think this executor as a system only. Okay. Now this,
Yeah, Anuj.
yeah. Go ahead.
For 4 executors, I think for one executor, 2 tasks, right?
Yeah, that we will discuss. So this is just a hypothetical number. Okay.
Okay.
Okay. We'll discuss this the logical way. So now this driver will send this task to the executor now because he created 8 tasks total. Uh, this depends on this cluster manager. Okay, so we need to configure this cluster manager according to our requirement. Okay, how fast a task we want, how parallel processing we want, everything. Okay, now let's say if everything is done, he assigned this 3 executor. Now this driver already created this plan. Now he'll send this complete task to this executors now. Who will send this thing to executor? This driver. Got it? Now from here, our executor will take care of each and everything. So what these executors will do now? Executors are nothing but your safe only, right?
Hmm.
No?
Yes.
So they will run in parallel, correct? Step 5, if you remember, shuffle. When they need to shuffle the data, if in ingredient exchange, if you remember, if something is missing in this particular safe kitchen, he'll ask from this and then the data shuffling will start. So step 5, maybe it will go for the shuffle or it will go for no shuffle. That we will learn why. Okay. And then the step 6, what it will do, this safe will send this data back to this driver, and then this driver will give you the output every time. So it will start from your reading your code and this output. So you're thinking you're just running your job in background. All this thing is happening for your Spark. Got it?
Yeah, Anuj, one doubt.
Yeah, yeah.
Like you have said that it driver will like send the task to the executor. Like which worker node it will also decide that to this worker node we have
No,
to send the task, or
no.
that will
It
taken
will
care
just
by cluster manager.
it will just say that will decide this guy, cluster manager. We'll
Okay.
come to that detail. Okay.
Okay.
First thing is we need to understand what is driver, what is cluster manager, what exactly these people are doing here. Okay, and then we'll go into the detailed way with our data. Let's say we'll take one small data. We'll try to understand where how it is creating in our local system. We'll understand each and everything like that. Okay. Now, very important insight here. Okay, first thing, this driver, where this driver will lives in. If we are running our Spark in local mode, we'll understand the local and cluster mode. In local mode or or cluster mode. So if we are running in our laptop, so local mode means our laptop only, right? Or we are making one complete machine in a cluster. Okay. So if we are running in our local mode, always your drivers lives in your machine only. Right. So driver is just making a plan. He's not doing any processing. Okay. So one important insight here is your driver and executor always communicate over network. Just remember this point. Okay. Now I'll just ask one question. Let's check how many of you understood it correctly. Now let's say if you have two worker node. Okay, each worker has two executors. Okay, and each executor has two core. So how many tasks can run in parallel? Any answer?
4.
Eight.
how
Eight.
how how, how? Can I elaborate little more?
Two core means for each task one core, right?
Aha, okay.
So when the executor has two cores,
So we have two worker node. Each worker node has two executor. Each executor has two core.
2 into 2 into 2, 8.
Okay. I'll ask one more question before answering this. Does a worker runs task directly? Yes or no? Yes or no? Okay. Next question. How many tasks can an executor run at the same time? These two questions. One I'll answer, this one. Okay. Equal to number of core. And for this one, yes or no? Does a worker runs a task directly?
It has to receive an order from a driver, right?
Okay. So what he'll receive? In our example, we are getting a pizza order. So in
Uh,
our Spark, he'll receive the data, the partition, right? Answer is yes.
yes.
Executor runs the task. Okay. Now, because one core is equals to one task at a time. Now we'll calculate it one by one. Okay. So let's calculate this one. Okay. Now we have two worker. Okay. So each worker has two executor. So 2 into 2. So how many executor in total we have?
For
Two
execution.
worker, two executor. 4. So can you tell me how many executor in total now we have? Because two worker having two executors. So what is the total number of executors?
One
4.
worker.
4.
For executors.
You're saying one worker having two executor or two workers are having?
Two worker having two executor.
Means one worker having one executor.
No, each one has two
Each worker
executors,
has
right?
to.
Ah,
Correct.
yes.
Each one has two executors. Right. Now each executor has two cores. That means now we already know, right? One core means one task, right? One core means one task. Here what I'm saying, each executor has two core, each executor. So total we have,
8 tasks.
yeah, correct. So my question here is, how many tasks it will run simultaneously? And starting question here is, how many tasks can run parallel in parallel?
8.
Okay. How? Total we have four executor,
But
right? Yeah. Go ahead.
we have two cores for every executor, right?
Correct.
So in that case, every executor can do two tasks at a time.
Correct.
So four executors means 4 into 2.
Correct. 8. Right. So total parallel task is 8. Everyone understood this one?
Yeah, Anuj.
Then I'll give one more. Okay. Now, let's say you have three worker node. Okay. Now, each worker has two executor. Okay, and each executor has 4 core. Now, same question. Uh, how many tasks can run in parallel?
24.
24.
24.
Okay, so answer like this. First one is total executor, total executor,
6.
6.
okay, and then total core,
6 into 4.
24.
6 into 4. So the parallel task,
24.
everyone is saying 24.
Yes, 24.
Okay, any doubt till here? No doubt. Then let me change this question little bit. Now think, if you have if you have 24 core total, okay, but only if you have 12 partition, then then how many tasks will run at the same time? How many?
24.
How?
12.
And will all the core will be used in this scenario?
No, only 12 core use because task is only 12.
You understood the question? What it mean? So we have only 24 total core. So the maximum task possible at once is 24, right? But we'll have only 12 partition. Okay. So the rule that we discussed is one partition is equals to one task, and one core can run one task at a time. Okay. Now, because we have 24 core available, but only will have 12 partition, so Spark will create 12 tasks because we have 12 partition only. So, how many tasks can run at the same time? Only 12, right? Because
12.
Spark cannot create more tasks than the partition always. Okay. So, in that case, your 12 core will remain idle. Okay. You can think like this. If you have 24 safes, okay, and you'll have only 12 pizza order, then your 12 safe will work and then the rest will just stand idle, right? So in this scenario, every time this kind of scenario will happen in your production, right? So this is very dangerous in your production.
But the work has to distribute equal parts, right?
Yes. So in that scenario, we'll have some of the optimization technique that we will discuss later. Okay. So we'll have those, how we can increase the parallelism, how we can increase the partition size. Those we need to do. Okay, how we can just uh, unnecessary we are wasting our resources, right? So we don't want to do that. So we need to see how we can manage those things. Okay, now I'll ask one last question. Maybe it is getting late. I'll ask last question now. I have 16 core and 200 partitions. Will Spark run 200 tasks at once? Just think very carefully. 16 core and 200 partition. Question here is, will Spark run 200 tasks at once? Yes or no?
No.
Why?
No,
Why?
But we have 16 cores only.
Mhm. 16 core and 200 partitions. So a rule means what? You need to give the a reason for everything, right? No is fine. Then why? Can anyone try to explain it? See, if you are having 5 to 6 years of experience, be prepared for this type of question. Okay. If you have less than that, that is fine. Sixteen core, 200 partition. Answer is no. That is correct. But why? Simple answer.
Uh, let's say 200 partition means 200 tasks, right?
Ah,
So, but we have 16 cores only. At a time, we can, we can do 16
hmm.
tasks only, right?
Yeah, correct, correct. So you can relate this with our pizza example also. Let's say you have 200 pizza, okay, and then 16 safe only. So can this 200 pizza cook at once? Is it
No.
possible? No. Answer is no. Only the 16 at a time, because only we have 16 safe. Okay. So here one important insight is, all this thing will make this note tomorrow. But here the parallelism depends on the minimum of what? Number of core and the number of partition. Okay. So the formula here is, you need to remember the minimum of total core and total partitions. Okay. So this formula give you the parallel task at a time. So this is very important. If you want to achieve any time goal, let's say your some of the task is taking 2 hours. Now you want to make it only 30 minutes. So while we'll look into the DAG, we are going to look into all these things, parallel task running, how we can increase or decrease those partitions. Those are the Spark optimization technique only. Okay.
Minimum total core partition.
This we will understand. Okay, with the practical thing. Okay. Everyone got this thing or any doubt? If we have any doubt, we can uh, discuss one more time. This is Spark architecture. But tomorrow we'll finish this core concept anyhow, because everything we already know. Now we know what is cluster manager, what is executor, what is driver. We just need to focus on just small thing. Okay, and then we'll discuss maybe this one we'll not going to discuss for now. We'll start with the Spark internal here. Okay, with the coding and all. Okay, and in this Spark part, we'll try to discuss the interview questions after each topic. Okay, let's say once we'll complete the core concept, we'll discuss the interview questions. Maybe because lots of scenario based questions will be there. Okay.
Anuj, there
Yeah,
are some transformations and actions, right?
yeah, yeah.
In that map and filter, is it same like Python or is it
Yeah,
different?
it's almost same, almost same. I told you na, if you're very good at Python, you'll easily understand the PySpark part. We
Okay.
already discussed. CSV is just on. Okay. This we already know in SQL. If no, we can learn this. This we already discussed. What is count distinct? What is sum, average, mean, max? It's the same thing. Okay. Almost everything is same. Here, the main important part is this one. This part. Predicate push down, column pruning, caching, AQE, broadcast join, skew migration, repartition, coalesce. So here we need to spend more time, because 80% of the question, interview question for the 4 to 6 or 7 or 8 years of experience people, right? You'll get the questions from performance optimization, this one, and then performance of this one. If you know this part, this two, you're good with the Spark. But we need to understand the coding part. We need to do lots of code and all. But the interview way, you just need to take this screenshot. If you want to learn and go for the interview, you can go. Okay, you can just, and it's very interesting. Spark is very interesting. When we'll start with the coding also, it will be very interesting part. All the questions and all. Okay, and we'll find some time to discuss this data warehouse concept one by one. Okay, maybe maximum of you already having the idea in this part. Okay, but we need to focus on this. Try to log in into AWS console, everyone, so that maybe after a week or 10 days, we can start with AWS also. Okay, once we'll finish with this part, Spark internal, this part, once we'll start with this two data frame operations, we can go and learn something in AWS. Okay. Yeah. Okay. Sorry, it's late, guys. Okay.